Hello students, I'm Dr. Z and I volunteer for the Children's Science Center. Today I'd like to talk to you about a very special application of electromagnetism called magnetic braking, or specifically it's called eddy current braking. Okay, what's all that about? Well, you know, about 200 years ago, scientists began to realize that there was something called the electromagnetic force. They knew about electricity, they could make batteries, they knew about magnets, but they didn't realize that there was a connection between those two. And what they discovered is that whenever electricity runs through a wire, like a copper wire, that electricity running through the wire actually creates a magnetic field around that wire. So that was the discovery of the electromagnetic force. Okay, so today we have a really interesting demonstration of that electromagnetic force and how it can be applied to a very specific application of stopping things, braking things. Not breaking them in pieces, but stopping fast motion smoothly into a slow motion. You know, electromagnets and electromagnetism are used just everywhere in our lives. Everything, so many things in our homes, our computers, our cell phones, our refrigerators, our washers, our dryers. There's electromagnetism at work in all of those applications. Okay. So what do we have here today? And this is something that you can do at home. I made myself a little cardboard tube, okay? There's a nice hole in it. And over here I have a tube of plain old ordinary aluminum foil, but it's a very thick tube. It's what they call an industrial grade roll of this tube, and you really have to buy that specially. You can get it on Amazon. And here I have a tube made of copper metal. Both of these obviously are metals. Aluminum is a metal and copper is a metal. And I also have a magnet. And this is a special magnet called neodymium. And you again can buy these on Amazon. And just a little reminder, remember that magnets are attracted to metals, but only certain metals like iron, but not to copper, not attracted to copper, nor is it attracted to aluminum, okay? And of course it's not attracted to the paper or the cardboard here. So let's do a little demonstration here. Here's my cardboard tube, and I'm gonna drop the magnet through the tube, and let's count how long it takes for that magnet to get through the tube. Ready? Let's count. Go. 1001. Whoop. It came out in almost less than a second. So it takes less than a second for that magnet to fall through that tube. Okay, let's take our aluminum foil tube here. You can see it's pretty thick. And you can see there's a nice big hole in there. And I'm going to drop this in, and let's see how long it takes for that to come through the tube. 1001, 1002. Let's try that again. Go. 1001, 1002. That's interesting. Now this tube is about twice as high as the aluminum one, and yet it took twice as long for that magnet to go through this tube. Okay, now we have here our copper tube, and there's plenty enough room in there for that magnet to fall through. And so let's see how long it takes. Ready, go. 1001, 1002, 1003, 1004, 1005, 1006, 1007. Wow! It took 7 seconds for that magnet to go through this copper tube. Remember, it took about a second to go through the paper, and they're about the same length. Let's try that one more time. Just to, you know, science is about repeating things and making sure that the same thing happens. So let's try that again. Ready, 1001, 1002, 1003, 1004, 1005, 1006, 1007. Wow. So it took almost 7 seconds. So what's going on there? Well, it's complicated. I won't lie to you. But here's what's really happening. When this magnet is falling through that copper tube, it creates a current of electricity through that copper tube. It's something called an eddy current. It's a current of electricity, an eddy current, and as it's falling through, it causes a current of electricity to develop through that copper tube. This is part of the phenomena of electromagnetism. And when that electricity is running through that tube, remember we said it creates its own magnetic field. So the magnetic field being created from the eddy currents in the copper tube is in opposition, or it's kind of fighting the magnetic field of the magnet itself. So that as it goes down, those two magnetic fields are fighting each other, and that's why it takes so long for this to go through the tube. Now, there are many applications for this, like in some trains, trucks will use it, and you know one of the most exciting ones is a roller coaster. You know how roller coasters are zooming, they're going so fast, and then they're ready to come back home, and you don't want this car that's going so fast to stop suddenly and everybody's going to fly out of the cars. They use these eddy current brakes to slow the roller coaster down real slow, nice and easy, and that's why you get that nice, slow, comfortable ride. Isn't that exciting? Okay, now in the next video you're going to see, I'm going to actually show you, if I can, how this magnet is kind of suspended as it falls through the copper tube and the aluminum tube. Okay, let's see how this works. Okay, students, so we're looking through our copper tube now, okay, from the top here, and I'm going to drop this magnet, okay, in through that tube, and let's watch what happens. Ready? 1001, 1002, 1003, 1004, 1005, 1006, 1007. That's pretty neat, isn't it? You could see how that magnet is really suspended, levitated in there. Let's try that again. Ready? 1001, 1002, 1003, 1004, 1005, 1006, 1007. Pretty neat. Let's try it with the aluminum foil, okay? Now this one you can see a little better, right? And let's see if I can do this without breaking my iPad. Here's the magnet. Ready? 1001, 1002. Whoa! Well, I didn't break my iPad. That's a good thing. But did you see how that really just levitated through that tube? Ready? Isn't that neat? Isn't science wonderful? Okay, guys, keep asking questions because that's what good science is all about. Hopefully we'll see you sometime soon at the Children's Science Center. Just ask for Dr. Z, and we can do some fun things together. Take care.